Okay. Uh, what did I do?
It wasn't working.
Oh boy.
No, don't tell me that. Then I've been the doo-doo. This is not the page you're looking for. Okay.
I like how he was on what planet was he on? Tatooine.
It's here. It's capital C for content. That was my problem. But I found it. We'll talk about it and then we'll figure out how to link the right way. Yeah, okay. Today, after having learned my lesson from trying to put if and recursion together, I figured we would hey, I'm broadcasting, right? Yes, I am broadcasting. We would talk about how to use objects, and then next week we'll talk about how can we define our own objects and classes, right? We have used objects, sort of, kind of. We have used weird objects. We use strings, and they're weird. But now we are going to use other kinds of objects. Objects are slightly different from primitives. We have used ints a lot, right? And primitives like ints are just values. 3 is 3. They don't have an identity. They are not, there is not 2 different trees. They're just 3 or 4, right? With objects, we'll see they have an identity and they allow us to define our own data types. In a way, what we are going to try to do is define our own vocabulary. The functions are verbs, and the objects are going to be our nouns. And so once we define our vocabulary, then our problem becomes really easy to express, hopefully. So if we define the right vocabulary and all the planets align right, then our problem becomes easy to express. That's what we are trying to do. We are trying to come up with our own things. We are going to play mostly with the point, rectangle, and dimension classes from the AWT packages. The AWT package is for drawing stuff into the screen. We are not actually going to draw anything in the screen. We're just going to use those because they're simple, convenient objects. A point represents a 2D point with integer coordinates. A rectangle is a rectangle on the screen. So it actually has a point, a width, and a height. And a dimension is just the width and the height. And I have here the actual links to the documentation from Oracle and stuff, which normally when you're programming, you're referring to that documentation a lot, just to see all the things you can do. As we had mentioned before, their full name is java.awt.point. So you either use their full name all the time, or you do just import java.awt.point once, and then you can just use point or rectangle or dimension. Does that idea make sense? You remember that stuff. You put import statements at the beginning of your code, right? Okay. How do we create an object? We create an object with the keyword new. So this new point of 1010 is creating a new object in memory. The object is of type point, and we are passing stuff to its constructor. Does that idea make sense?
The video you posted, Dr. What's his name?
Chasteen.
Chasteen. That's actually a really good video. I was watching that earlier.
Chasteen is good.
Yeah. So if y'all haven't watched that, I would definitely watch it.
But now you're doomed. He's good. He's good. So the university took him away. He's now doing higher up stuff.
So it used to be here?
He is officially here.
Oh,
He's
okay.
just not here.
I was wondering why I only had like 20-something views. I was like, man, good
He,
video.
I think so. I think that's the video there, probably.
There's only one for
Yeah.
this week.
Yeah.
Yeah.
And I've been posting his videos all the time.
Mhm.
Yeah. He was up until December department chair for software engineering. He's really a game design guy. He's a game design guy. But he's good, so they stole it.
He has, he lays it out so that you can really see it, in his slides, everything flowed together. Because I took a IT introduction to Java last semester, and man, it was not laid out like that. It was a lot harder to understand, but anyway.
I'll go rewatch the video.
Have you not seen it?
I did at the beginning of the semester.
Yeah.
I watched all of them, but now I can't remember what was where.
Yeah.
Like-
Well, have you ever spent 2-3 months trying to figure something out, and then you see it explained
Like-
in 20 minutes?
Yeah.
Yeah.
Good. So this new creates the object, and we normally want to assign it to a variable, because if not, we just create it, and if we don't have a reference to it, we'll be in trouble, right? So our normal thing is like this. This declares a new variable of type what? Point. What's the name of the variable?
PT1.
PT1, right? And it assigns to it a new point, right? And we'll see what that 1010 is, right? The next line creates a different variable. Objects have identity, right? They are things in memory, and we can distinguish between two things that have the same state. They also have state. Objects keep variables. They know not just who they are, but what they are. Does that make sense? So in this case, the state that we're passing to the constructor are the x and y coordinates, and that you know by documentation, right? So that would tell us the first point is the point at 1010, and the next one is the point at 57. Does that make sense? The syntax looks a lot like function calls. And we'll see that it is a lot like a function call. Now, once we have that, these objects now have state and they have methods, and we can reference those things by putting a reference to the object, usually the variable name, and then the dot operator, the period operator. In the case of a point, points have x and y things. Let's create that project, or go play with a project and start doing code. Points have x and y, so we can do p1.x and those kinds of things.
What's hard to understand is the constructor, which is in the other class, the user-defined class, and how it relates to the object in the driver class.
Yeah, we'll be doing that stuff mainly next week.
Oh, okay, yeah.
When we define our own classes, we'll probably give depending on time, we'll probably get an intro this time, and then we'll really go into it next class. And hopefully using these things will make defining them really easy, or slightly less weird. How about that? I have my sample. Perfect. So here we have created one point, PT1. Can you guys see this? Is it big enough? another point PT2, and another point PT3. We can do stuff like this. Print PT1.x. What's PT1.x gonna be? 10, right? So if we were to run this thing, we will see 10. Woohoo! Now, maybe at some point in time, I can figure out how to put this back. Reset. Yes, I want to reset this thingy. Go to the bottom. Yay!
It just needs an undo arrow.
For when you move stuff around?
Yeah.
Yeah. That would be so nice. Hide, you thingy. And then maybe if I run it, the console will appear down there. Yay! And it printed 10. Now, we can also, that is part of the state, right? The point knows its state, it's X and it's Y. We can do pt1.x equals 12, and that changes that state, right? Now, notice that each point has its own X. So pt2.x would print something else, right? What would it print? 5, right? We can do this. And print this again. And so now we'll get 10, then 5, then 12, right? And we get 10 and 5 and 12, right? We could be printing Y's instead of X's, right? And that would do different things. It has an X and a Y. That's all the state that it has, probably. It's all the state we're going to look at. How about that? You never know until you go look at the documentation. They may store color or something like that, because they were designed for printing, but we're only going to use its X and Y. How about that? Now, objects also have methods. They are almost like functions, but they operate on an object. The first thing, so we can call this pt1.getX. And that is a method. This is basically equivalent to pt1.x, right? But it's a method. Does that make sense? GetX just returns that X. It is fairly common in Java to have these accessor functions. And by convention, they're called get, and then Java uses camel case as a naming convention. So you will start with a capital with the name of the variable. Your X is lowercase when we are doing it here, X or Y, lowercase, right? Here, since they are now part of a word, they become uppercase, just the first letter. Does that idea make sense? almost every programming language has that thing where spaces break words, and so you're not supposed to use spaces in your names. And so they come up with conventions for how to name things. In C and C++ and other languages, the conventions to use underscores instead of spaces. In Java and a bunch of other languages, the convention is to use camel case, to put uppercase at the beginning of each word. And somebody thought that that looked like the humps of a camel, so we called it camel case. Let's forget, and we'll come back to the nodes. There is a couple of useful methods. Every object has these methods. We'll see later that there is inheritance, and we'll see why they have these methods. But the toString method is very useful. It is supposed to give you a string representation of an object. Tells you, right? Tell you what the object is in a way. Does that make sense? So if we were to run this, we would do this get y, which would do 12 because we just changed it to 12. And then it would print something that says, I'm a point and my x is 10 and my y is 12. That's what it prints. That is fairly useful because it kind of tells you what's the state of that thing. Does that make sense? Now, let's stop changing our things. Well, let me tell you one more bit of magic. Java will convert anything to a string if it sees that it should be a string. So it will call the toString method for you. It's one of the few things that it does. So we can just do println pt1, and that will call toString on it and then print that string. Which is why it works when we do println and we pass an int. Actually, it converts that int into a string and then prints the string. Println only prints strings. Sort of, kind of. Does that make sense? Now, let's talk about identity and state and things like that. Let's forget about this point for a second. We have P1 and P3. Are they the same?
No, because we modified y in P1.
Let's assume that we don't modify anything. Let's see, what would happen? We print those two things. Are they the same?
No.
No, yes. Who says no, and why not?
Because they're held in different places in memory.
Okay, they're not the same. They are twins in a way. Does that make sense? What makes them not be the same? That if I do this, I didn't change both of them. Does that idea make sense? They're not the same. They are two different objects that just happen to have the same values. Objects are boxes, they contain things. There are two boxes that contain the same things. Right? Can we have two variables point to the same object? Sure we can. And we have a new point, which we're calling alias, and it points to PT1, right? If we were to print it, this one would print what? Point of 510, right? This one would print what? 1010. This one didn't change. This one would print what? 510, because it is the same as. Does that idea make sense? Now, in Java, we have, and let me undo this. Now they are almost the same, right? I can ask, is PT1 equals PT3? Are they the same? In Java, they are not the same. Does that make sense? So this would print false. What about PT1 equals alias? That would be true. They are the same. However, I can also print every object has a method dot equals that tells you a user-defined version of they are the same. Rather than the exact same object, they are twins. Does that idea make sense? And that would, hopefully, for the point, return true. If we were to print this, we would get false, true, true. Does that idea make sense? Once you understand this idea of identity versus the state in each object, right? An object is a thing, just like in real life. We have a bunch of chairs that are the same, but they're not the same chair, right? And so if I destroy one, the other ones are still there, as opposed to having one chair. Does that make sense?
Is that the reason why PT1 does not equal PT3? Because they're just two separate entities?
Exactly.
Even though they have the same 10.
Exactly. There are two separate entities with the same state.
I gotcha.
That kind of is the most basic thing. Once you understand this, then everything else kind of works. You can still get really confused because aliasing is evil. Sometimes necessary, but it's evil, right? Because it would be really cool if I have one name for each thing and only one name for each thing. So when I tell you chair one, you know which chair I'm talking about, right? As opposed to that chair, and I'm pointing and there's 10 different chairs in the general area, so you don't know which one I'm talking about. Does that make sense? Problem with aliasing is that now we have 5 names for the same thing. Now you are Bob, and also Joe, and also John. So when people start talking about those things, now it's hard to, when they're talking about Bob or Jane, it's hard to remember that they are the same. So they tell you Bob did this, Jane did that, Joe did that other thing, and they are always talking about the same person. So that would be really confusing. Right? Normally, when you write, you try to, especially when you write and you're trying to be understood as opposed to be poetic or something like that, you always refer to the thing with the same name, right? Because if not, people are going to get confused. That's what happens when you have aliasing. It is fairly easy to get confused.
Is this related to pointers in C++ or casting
Yes.
by value?
Don't tell anybody, but these are pointers. I mean,
Java didn't have this thing. I'm just kidding.
they are references, they are the same thing as pointers. But don't tell anybody, because Java is easy and simple, it doesn't have pointers. If you haven't seen C or C++, don't worry, Java is easy and simple, it doesn't have pointers. Don't get anxious. Pointers can get you even more confused. But this tends to be confusing enough. You should be careful and make sure that you understand what you're talking about and try to keep aliases to a minimum. Sometimes you have to, but see if I didn't skip anything interesting. Yeah, sorry.
It'd be pretty rare if to need an alias.
You're creating aliases all the time. That's like when you call a function, you pass it an object. You're actually passing a reference to that object, so you just created a new name for it. And so if somebody else keeps a copy of that thing for whatever reason, now you have. So it's fairly easy to, if you don't do, I try as much as I can for most of my functions, and if you have seen most of our functions, either they tend to not affect state. They compute stuff and return it. If you can, that's good. The only places where we have affected state is when doing input-output. There is no other way, right? When you read from the keyboard, you just affected state. When you write something to the screen just changed. There's nothing to do about it. But as much as you can, try to keep most of your functions being just functions. And your and that should hopefully keep you not confused. And it's not just you, it's you on a Monday morning or you on a Friday afternoon, right? You can fairly easily get confused. Quick exercise about aliasing. We define 2 points. Alias points to P1. Alias.x equals PT2.x. Now alias is PT2. Alias.y equals 5. So sum x is PT1.x plus PT2.x, and sum y is PT1 plus y plus PT2 plus PT2.y. What's the value of sum x and sum y? No. Let's do what happens here, right? Alias is PT1. Now, alias.x equals PT2.x. What did we change? Of who? Of PT1, right? Yes, sorry.
Almost like an accumulator or something.
Yeah, it's just random.
Oh.
It's just to confuse you, right? It's, the only point of this exercise is to confuse you.
Because what that says is alias x equals alias x plus PT2.
Yes. So alias x is 10, right? Now it's gonna be now 15. Does that make sense? So now PT1 is 1510. Now, alias now points to PT2, and alias of, so PT2's y is gonna be +5, right? So PT1 is 1510 and PT2 is 510, right? But we change this to y. You need a smart board, but this board is really, really dumb. Sorry. So some x and some y would both be 20, right? 15 plus 5 and then 10 plus 10. And if you don't believe me, what can we do? Yes. Even if you believe me, maybe I confuse myself. That would never happen. Yay, I didn't confuse myself. Just a review, right? We have toString. For every object, we have toString and we have equals. There's actually one more method that we may talk eventually, which is hash. This idea of equality versus identity, right? Equal tests for identity. Are they the same object? Whereas dot equals tests for are they twins or are they equal? What's the definition of equal? Whatever the heck whoever designed that class came up with. Does that make sense? Maybe somebody says, I'm doing points in floating point, and so as long as they are within 0.1 of each other, then they are equal, right? So you could come up with different definitions of equal. Another example, we have rectangle, and one of the constructors takes 4 arguments, and that would be telling you the width and the height. Right? So it's a rectangle of 1012, and it's 5 units wide and 7 units high. Important thing. What are our coordinates? So we can talk about which corner are we talking about, right? When we are doing rectangles. There are 2 obvious coordinate systems, at least in the US. How do you do coordinates? You remember math. You remember analytical geometry, that kind of stuff. Can you graph something? No. Cartesian coordinates, right? Your x goes this way. Oh, something to paint with. That's something that paints? No. Never mind then. Okay. God, no. Your X goes this way, right? And your Y goes this way, right? And it grows towards the top, right? That's one way of doing coordinates. However, there's another one that's commonly used in computers, and it's how we read, right? Where is the first line when you read in English? The first column is always on the left, but the first one is at the top, and it grows down, right? The 10th line is below, right? So when people starting doing screens and characters on the screen, it makes sense to number them that way. So 0 is actually at the top of the screen, and however many you have is at the bottom of the screen. Does that make sense? Thank goodness we read left and right, left to right anyway, so the X coordinate is always the same. So when people started doing graphics, people always get confused. Which one would make sense? They both make sense. They're just different. For AWT, they use the one like the reading. So the 0 is at the top and Y goes down. Does that make sense? So we're going to follow the same convention, and we are going to say that the rectangle has its top left corner. That is the one with smallest X and Y. And then the width and height. Does that make sense? That's going to be important, mostly in the assignments, but also in these examples, right? I can create a function is to the left that takes 2 points, P1 and P2, and it's going to return whether P1 is to the left of P2, right? In order to talk about left and right, what do we care about? Only X's. We don't care the Y, right? And so we would say that a point P1 is to the left of P2 if its X coordinate is less than the other guy's X coordinate, which we express in programming like this. Does this make sense? Yes. Other examples, right? We can do get area of a rectangle. How do you get the area of a rectangle? Multiply width times height, right? So that would be a function that gets the area of a rectangle. Do you care about where the rectangle is on the screen to calculate this area? No, it's the same area, right? So you only care about certain parts of the state, and that is normal. And by the way, your assignment requires you to do this 700 times with different things. You can imagine I'm giving you is to the left, so the assignment does is to the right and is above or one of those, right? Similar kinds of things. Now, one important thing in when you are passing objects to a function, you're actually passing a reference to the object. You're not making a copy. When you pass primitives, you are making a copy, so you can change your parameters and nothing actually changes outside the function. When you're passing an object, you're passing a reference to the object. You can think of it as you're passing the object as opposed to a copy. So if you change it inside the function, it stays changed. Does that make sense? So we can define functions, methods like this, right? I don't call them functions because a function corresponds to the mathematical idea of a function where you actually don't change anything, right? If you change it, it's not a function anymore. It's a who knows what the heck. And so we can define a method grow rectangle that takes a rectangle and a factor and grows the rectangle by that factor. So it changes the width and height, multiplying it by that factor, right? If we do this, that rectangle stays changed, right? Does that idea make sense? Copy this. Put it here. And go play.
So did the people who came up with Java decide to pass primitives by value and object by reference just because that's what you usually do, I guess?
Yes, because partly by that's what you usually do, and partly by how computers work and that kind of stuff. It is really hard, or it's potentially a pain in the neck to create a copy of an object.
Yeah.
Whereas for primitives like ints and floats and things like that, it's the same effort to make a copy or not. So it's kind of nicer to make a copy.
In C++, because you have both options, but I don't think I ever use anything but a copy for a primitive and like pass the objects by reference. I mean, it's like you have the option to do both, but I don't think I've ever seen a situation where we do.
You can pass objects by copy, and it's very convenient. Many times it fixes all the problems you ever had with pointers and things like that, because now I'm making a copy. Yes, it's inefficient. Who the hell cares? It works. My assignment now works. Because I know that it cannot change. I'm passing a different copy of the whole thing.
Yes, there are reasons you would want to do that.
Yeah, performance-wise, it tends to be bad, but so this makes sense in Java, but. So this would create a rectangle at 10, 10. Let's make it 5, 8. You can do system.out print line. What would this do? Oops.
Everything by 2.
Yes. What's everything?
All 4 coordinates.
No.
Oh,
Only width and height,
okay.
right? So we're still at the same place, except that now we are bigger. So if we were to print this, what would we get?
Um, 10, 20, 5, 16.
Yeah, 10, 10, 10, 16.
Oh,
Whichever order you are mentioning them. That would be x is 10, y is 10, width is 10, and height is 16. Again, this is dangerous. I just gave my object to a function and it messed it up. It changed it, right? So make sure that when you name your methods that change things, they have names that tell you, right, grow rectangle. So, well, that's probably growing it, right? So that you don't get confused, because once you get 500 lines of code, is my object being changed or not? right? So it can become a lot harder to track things. The first option that you should strive to is not mess up your objects, right? I create a function that returns a different rectangle that's twice the size, right? But if you need to change them, make sure that you name them with something that tells you, I'm going to mess up your object. Does that idea make sense? Cool. Let me go play. Well, let me go show you the assignment. But I can't because I'm evil. That's what I get for being evil. But I can. I cannot. No, I cannot because I'm evil. I will go download it and what? Because let me on the assignment, you will be asked to use this class. Let me create it here. Girl. Usually doesn't happen, but sometimes cancel. Okay. New class. Oops, they already exist. So let me open them. What is it? Maybe I have it with the exact same thing. Now we have a person Java. Now person is going to have first and last name and age. So we're going to create, again, we use the keyword new person. Let's call him Orlando. Make him 40. Close enough. We can print this person, right? And that's going to be its state. Hopefully it prints nicely. Proceed. No. So person, right? That's what it has. We can do kind of the standard p1.get first name, get last name, and get age. And create more people. Your assignment is going to involve doing a million functions like this over and over. It's going to be really simple, but involve this kind of stuff. How do you create objects? What operator do you use? What keyword do you use to create objects? New, right? What do objects have? They have an identity and state, right? They have their own variables, right? And different objects have different state. They have their own internal variables. Does that idea make sense? Which methods do we have on every object? Rectangle is one class, right? One kind of object.
You have an accessor method.
We have accessors like get this, get that, but which ones are in every object? Constructors, but we have toString and equals, right? Does that make sense? Sorry? toString and equals. Now, they may not do what you want, but they're always there.
We don't have to have destructors.
No, in fact, in Java, you normally don't have destructors because Java has garbage collection. Basically, this is the idea of what happens when an object is not needed anymore. Right? What happens when an object is not needed anymore? Well, how do you know if an object is not needed anymore?
It's not pointing to anything.
Nobody is pointing to it, right? So nobody has a reference to it. Nobody can talk about it, right? So we know that it's not needed anymore. What happens to that object?
Becomes null.
Actually, the answer in Java is, why the heck do you care? You cannot access it anymore. You cannot talk about it. Then why the heck do you care, right? And your answer may be, I care because it's occupying memory and I may need that memory, right? Java's answer is, well, when you need that memory, right, I'll make sure that it's dead. I'll kill it, drive a stake through its heart. It will be dead, dead, dead. But for now, don't worry about it, right? That is called garbage collection. It will eventually, if and when, get just deallocated, right? The memory is not used anymore, so it may be reused by somebody else. but there is no destructor. In C++, there is a concept of a destructor. You know when the object dies, and when it dies, you can tell it do this. In Java, there is no such thing. It's just, who cares? If you ever need the memory, then I'll take care of it. But does this make sense? Shall we take a look at how we can define these kinds of things? Just to get you an idea, and we'll go over this next class. But actually, first of all, do you guys have any questions about how to use objects, how to access them, how to create them?
My questions will come with the assignment time.
Yes, and you can ask questions, right? That's good. You can ask the questions then. Yes. We can create our own class. Let's say my point. For now, let me add more noise. Yes. I can define my own point class. Forget about the static. We'll talk about it later, but that allows me to keep it here. I can define it as something that lives, that has an X and a Y, and they're all public, so I can access them. So I can do here my point P1 equals new my point, and then P1.x equals 10, P1.y equals 12, and stuff like system. Does this idea make sense? Is this super simple?
For my point, why did you put public in front instead of just, why did you declare the public inside of the method instead of outside?
Well, this is not a method, it is a class, right? And actually, this public inside affects the fields, not the class. The class is not public, so actually nobody outside of this using objects.java can see the class. But if you can see the class, then those methods are public. Those fields, sorry, are public. Example. And we'll talk about it next class. For now, assume it's noise. Does this make sense? This allows us to create different my points, right? Does this idea make sense? Let me just do one more thing, and then I'll let you go. Your brain's primed. I can create methods. What's the distance to the origin of a point? It's going to be the square root of x squared plus y squared, right? Either go refresh your math or believe me. If I were you, at some point in time, I will go refresh my math because that stuff you should know, but believing also works. Now, inside the object, how do I refer to my stuff? right? The verbose way, right, is this refers to myself. Does this idea make sense?
So it passes whatever you put in front of distance to origin is this.
Exactly. So when I do this is that P1 in this call, right? If I call P2 dot distance to origin, then this will be P2. Does that idea make sense?
That's how you write x squared plus y squared.
This x times x plus y times y, right? Yeah.
Oh, Pythagorean theorem.
Yes, it's Pythagoras' theorem in analytical geometry. Does this idea make sense? You don't need that for this assignment, but we'll talk about it next class, and hopefully this will have primed your brain. So when we talk about it, it'll be, yeah, of course, it's easy. Hopefully. The assignment requires you to define a bunch of these kinds of functions. Don't overthink it. It's incredibly easy. It's more to train your fingers to type this dot x or to try to type p1 dot x and p1 dot y and those kinds of things. Does that idea make sense? So the assignment should be fairly simple, not super easy. If you end up spending 10 hours on it, then it may not be that easy. But it should be fairly simple, and it's more to train you on typing that kind of stuff.
Can you leave some of these examples that we did in class?
I will post them, and actually the assignment gives you 1 million of them. Like, as usual, right? I give you stuff, and I give you some kind of what I was doing when I was thinking about it, and I actually give you is to the left. And now I ask you to do is to the right, which I give you is above, and I ask you to do is below.
So the examples are actually
Yeah,
hidden in the assignment.
yeah, or
Okay.
close. When we do this stuff in class, we may end up with a slightly different example. But so you have millions of examples. So you end up doing, chances are that each one of these things is like one line. I'm just asking you to do a bunch of one-liners. Something like 7. Not yet. That will be next assignment. You'll have to create a couple of classes.
It's like 3 weeks ago in C++.
Well,
And data structure, I shouldn't have taken
data structures assumed that you had taken this
Yeah.
class, right?
Yeah, I should
So-
have waited to take that class.
Yes.
Class is crazy. Yeah.
Yeah, I should have dropped
data structures assumes, right? It starts from where this class ends, right? So
it's not been. It's kind of nice because it's like kind of like trial by fire, like sink or swim. And then I come to this and it's like, wait a second, that's not that hard. Why did I have such a hard time? But yeah, it is tough seeing it and then coming back to this. I understand it after seeing this.
don't worry, in your masters you'll take the adult version.
Yeah.
I mean, the thing is they all build on each other. And actually, if you have never done programming, then this class will be hard as hell, just because you have never seen it.
Exactly. I can set that. Into that.
But hopefully it will click, and then you'll take it again next semester and ace it. Or take. Yes.
I think Java is becoming my favorite language because I took like some online Python classes, and then now I'm taking. And I thought Java was hard, but now like compared to C++, like I feel like it's so good. I get to do a Java project.
Java is not bad. Yeah. And you will see throughout your career, you will probably learn a bunch of different programming languages. And so once you have done this in 5 different languages, then this stuff is like, it actually helps to do it in different languages. But right now, focus on Java, and we'll get through this. Let me stop this thingy, maybe.
Are you teaching anything during the summertime?
Probably not. This guy. Probably not.